Hi guys, today I'm solving Physics 9702 paper 2. This is AS level structured equations, October, November 2022. So I'd like to take you to the question paper. So here is the question paper 9702. October, November 2022. The paper is 1 hour and 15 minutes. I'll try my level best to keep time. I'll not go through the instructions. You can go through the data given. You can also check through the formula given. I'll go straight to question number 1. State what is meant by work done. Now it's wrong for students to define work done as just force times distance. It is actually force times displacement in the direction of the force. So work done is going to be force times displacement in the direction of the force. Force times displacement in the direction of the force. Use the answer to A to determine the SI base units of power. So since we know that power is the same as work done divided by time taken, or it therefore implies that this is going to be the same as work done is force times the displacement divided by T. So I'll list the units. So power will be force. Force is in kilograms, meters per second squared, then times displacement, which is in meters, divided by time, which is in seconds. So I'm going to simplify this further. It will be kilograms meters squared s power minus 2 divided by s, which becomes s power minus 3. So this is kilograms meters squared s power minus 3. So this is kilograms meters squared s power minus 3. The maximum useful output power P of a car traveling on a horizontal road is given by this expression here. P is equal to V cubed B, where V is the maximum speed of the car and B is a constant. For the car, P is 84 kilowatts plus or minus 5%. B is 0.56 plus or minus 7% in SI units. Calculate the value of V. So I'll just make V the subject here. So V cubed is going to be P divided by B, which means V is going to be the cube root. V is going to be the cube root. Cube root of P divided by B. So I'll just make a substitution here to be the cube root. There's a 3 there. The cube root of 84,000 divided by B, which is 0.56. Okay, so I have 84,000 divided by 0.56. Then I find the cube root. So I'll say shift cube root of the answer, which is 53.1. So this is going to be 53.1. Then determine the absolute uncertainty in the value of V. So remember, V is going to be P divided by B. This is to the power of 1 over 3 because it's the cube root. So it means here the power is multiplied by the percentage or the fractional uncertainty. So I'll say the percentage uncertainty in V is going to be 1 over 3 into brackets the percentage uncertainty in P plus the percentage uncertainty in B. This is going to be 1 over 3 into percentage in P, which is 5%, and percentage in B, which is 7%. So this is 5 plus 7, which is 12, divided by 3, which is 4%. So the answer here is going to be 4. So this is, the question wants absolute. This is percentage, okay? So the absolute uncertainty, this is percentage uncertainty. Let me find the absolute. So the absolute uncertainty in V is going to be 4 divided by 100 times your value of V, which is 53.1. So 4 divided by 100 times 53.1, which gives you 2 point. So that is 2.1. So it's plus or minus 2.1. Okay, so that is going to be the absolute uncertainty. The percentage, 5 plus 7, I think that is 12 divided by 3, which is 4%. Then the absolute is going to be 4 divided by 100 times 53, which is plus or minus 2.1. Or you can write one significant figure plus or minus 2. Okay. A spherical balloon is filled with a fixed mass of gas. A small block is connected by a string to the balloon as shown in the figure here. The block is held on the ground by an external force on the string so that the string is vertical. The density of the air surrounding the balloon is 1.2 kilograms per meters cubed. The upthrust acting on the balloon is 0.071. Of course, we know that the upthrust acts vertically upwards. And we also know that the weight must be acting vertically downwards. By using Archimedes' principle, calculate the radius r of the balloon. So, of course, by Archimedes' principle, the upthrust is going to be equal to the weight of the fluid which the object displaces. So it is the weight displaced. The weight of the fluid displaced. So a submerged object displaces its own weight. So the upthrust is given as 0.071. And remember, the upthrust is the weight of the fluid which is displaced. So 0.071 equals to the mass of the fluid which is displaced, which is density of the fluid displaced times g times the volume of the object, because the object displaces its own volume. Okay, but also remember it is the balloon is going to be considered to be, I think it is spherical. It is a spherical balloon, so V will be volume of a sphere. So this means 0.071 is equal to density times g times 4 over 3 pi r cubed. So I'm just going to make r the subject. So r cubed is going to be 3 times the density, which is 0.071, divided by the density. So that was times upthrust. The density is 1.2 times g, which is 9.81 times 4 pi. That is r cubed. So I want to find r. So 3 times 0.071 divided by 1.2 times 9.81 times 4 pi. Okay, so I have that, and then I will have to find the cube root. So shift cube root of the answer, which is 0.11. So I have to find the cube root. So it means r is equal to 0.113. So this is 0.113 meters. Total weight of the balloon, string, and the block is 0.053 newtons. The external force holding the block and the ground is removed, so that the released block is lifted vertically upwards by the balloon. Calculate the acceleration of the block immediately after it is released. So first of all, let's find the mass. The mass which is being lifted, because they have given us the weight of the balloon, string, and the block. So the mass, of course, the mass is going to be the weight divided by g. They gave us the weight as 0.071. 0.053 divided by G, which is 9.81. So this is giving us the mass. So we need to find the resultant force which causes an acceleration upwards. Remember, the up thrust is upwards and the weight is acting downwards. So the resultant force, remember it is given by mass times acceleration, is going to be 0.71. I'm always making a mistake. 0.071. 0.071, which is downwards. This one is downwards. Sorry, it is upwards because it's up thrust. So it is 0.071 upwards minus the weight, which is 0.053, which is downwards. I think the resultant here is, let me check, 0.071 minus 0.053. 0.018 newtons. So ma is equal to 0.018 newtons. So the acceleration is going to be 0.018 divided by the mass, which is 0.018 divided by 0.053 over 9.81. Okay, so the 9.81 goes up. So I'll just say that times 9.81 divided by 0.053. So this gives me 3.33. So this is 3.33 meters per second squared. The balloon continues to lift the block. The string breaks as the block is moving vertically upwards with a speed of 1.4 meters per second. So it was moving vertically upwards with a speed of 1.4 meters per second, and then the string breaks. So that means it may first continue slightly vertically upwards, then it falls downwards. So remember, it was going upwards with a speed of 1.4 meters per second. After the string breaks, the detached block briefly continues upwards. Of course, here it reaches a velocity of 0 before falling vertically downwards. So if it falls downwards, the block hits the ground with a speed of 3.6. So if this is the ground, it hits the ground with a speed of 3.6 meters per second. Assume that air resistance on the block is negligible, which means A is equal to 9.81 and it is constant. So the equations of motion can apply. By considering the motion of the block after the string breaks, calculate the height of the block above the ground when the string breaks. So if it breaks from this point here, we now want to find this height. Okay, so I'm going to just break this into two parts for simplicity. I will find the distance upwards. I'll call it h1 and I'll use v squared equals to u squared plus 2as. So I'm considering it going upwards. So I'm considering it going upwards to the maximum height. It is going upwards. So the velocity at the highest point is 0. So 0 squared equals to initial velocity, which is 1.4. This is squared. It was moving against gravity, so I'll say minus 2 times 9.81, then times, I'll call the h here, I'll call this height here h1. So that's h1. So h1 is going to be 1.4 squared divided by 2 times 9.81. Then I'll consider it going downwards. Let's consider it going downwards and use the same formula. It is starting from the highest point, so initial velocity is 0. Then it reaches the ground with a speed of 3.6. So I'll say 3.6 squared is equal to the initial velocity when it is just starting falling downwards, which is 0 squared. So here, because I considered it from the top, I will not put a negative. Instead, I will say just plus 2 times 9.81 times, I'll call this height h2. This one here is going to be h2. So h2 is going to be equal to 3.6 squared divided by 2 times 9.81. So the height we want, which is this h here, is going to be the difference. So The height is going to be the difference. The height we want is going to be 3.6 squared over 2 times 9.81 minus 1.4 squared divided by 2 times 9.81. So I'll just press the calculator. Of course, this is the same as 1 over 2 times 9.81 into 3.6 squared minus 1.4 squared. So I'll simply say 3.6 squared minus 1.4 squared divided by 2 times 9.81. So this is giving me 0.560 or 0.56. 0.56. So that will be the height, h. The string breaks at time t equals 0 and the block hits the ground at time t equals to capital T. On the figure, sketch a graph to show the variation of the velocity v of the block with the time t from t equals to 0 to t equals to capital T. Remember, t equals to 0, v is 1.4, and t equals to capital T, it hits the ground at time t equals to capital T, v is 3.6. So the graph should start from 1.4 and stops at 3.6. But remember, it comes back, so this is going to be negative. Okay, so I look for 1.4. The scale on the vertical is 1 divided by 5, which is 0.2. So the 1.4 is here. Then I will look for negative 3.6. So negative 3.246. So 3.6 is going to be here. So I'll just draw a straight line through these 2 points, of course, to cross the x-axis because there's a change in direction. That is not very precise. Okay, so that is going to be the graph. Here it starts from 1.4 and here it stops at negative 3.6. It is negative because there's a change in direction. Initially it was going upwards, it reaches maximum height where velocity becomes 0 and then it returns to the ground with a speed of minus 3.6. State what is meant by center of gravity. Of course, the center of gravity is a point on an object, or it's a point where all the weight of an object is considered to act. Point where all the weight of an object is taken to act or is considered to act. All the weight of the object is considered to act at that point. That is what we call the center of gravity. A uniform beam AB is attached by a frictionless hinge to a vertical wall at end A. The beam is held so that it is horizontal by a metal wire CD as shown in the figure. The beam is of the length 0.96 meters and weight 23 newtons. A block of weight W rests on the beam at a distance of 0.2 meters. The wire is attached to the beam at point D, okay, which is a distance of 0.4 meters from end B. The wire exerts a force on the beam of 45 newtons at an angle of 37 degrees to the horizontal. The beam is in equilibrium. So remember, it was a uniform beam. So if the whole of this distance here is 0.56 plus 0.4, which is 0.6, then it implies that I have to divide. Let me check first, my mathematics is not good. 0.4 plus 0.56 plus 0.4, that is 0.6 divided by 2. So the distance here is going to be 0.48 meters. Because it is a uniform beam, its weight acts at the midpoint. So I was looking for the midpoint, which is 0.56 plus 0.2 plus 0.2, then divide by 2. So that is 0.56 plus 0.2 plus 0.2 divided by 2, which gives us that distance there. Now the weight of the beam is causing a clockwise moment. W is also causing a clockwise moment, but there is a tension in this beam which has a vertical component vertically upwards. So I have to resolve 45 to the vertical. If I use the angle of 37, if I take it to the vertical, it will be 45 sine of 37. So instead of looking for perpendicular distance of 45 at an angle of 37, I will just use 45 sine 37, and the perpendicular distance will be this distance here, which is 0.56. Okay, so calculate the vertical component of the force exerted by the wire on the beam. So we have already seen that component is equal to 45 sine of 37. 45 sine 37, that is 27.1, or simply 27 newtons. By taking moments about A, calculate the weight W of the block. So we say W causes clockwise, so it is W times its perpendicular distance, which is 0.56 plus 0.2 plus 0.2. Hope I guessed it right, okay. 0.56 plus 0.2. No, it's just 1, not 2. It is 0.56 plus 0.2. Perpendicular distance of W from pivot. It's this distance up to here. Then plus 23 is also acting anti-clockwise, which is 0.48 perpendicular distance. Should be equal to the anti-clockwise moment, which is the component of the tension, which is 27 times, or 4 sine 37 times perpendicular distance, which we said is 0.56. Okay, so I have to simplify this. W times, I think this is 0.76 plus 23 times 0.48 is 27 times 0.56. I'll just press my calculator. 27 times 0.56. I'll subtract 23 times 0.48. Then I'll divide by 0.76. So this is giving me 5.37 or 5.8. I mean 5.4. The hinge exerts a force on the beam at the end A. Calculate the horizontal component of this force. So the hinge is exerting a force here, which must be acting in that direction and should be opposite to the horizontal component of the tension. This one has a horizontal component in that direction, which is balanced with this force here. The horizontal component here is 45 cos of 37. Okay, so that force is the horizontal component. So that is 45 cos of 37. So 45 cos 37, that is 35.9, approximately 36 newtons. The block is now placed closer to to point D on the beam. State whether this change will increase, decrease, or have no effect. Let's check. So I'm going to quote the same working that we had before. Remember, the weight W is remaining constant, and we got it as 5.4. So I'll say 5.4 times its perpendicular distance. So the perpendicular distance here was 0.76. Now I'm going to reduce it to 0.6 because they are saying it is moved closer to D. So the perpendicular distance has decreased. Let's say it is now 0.6 plus the weight is 23 times perpendicular distance, which was 0.48, should be equal to t. Now we don't know t, but the angles remain the same, t sine 37, then times 0.56. Let's see if t is greater than 45 or less than 45. So I'll just check my calculator. And of course, the no effect part is wrong. So I have 5.4 times 0.6 plus 23 times 0.48 divided by 0.56 sine of 37. So I'm getting t as 42.3. So it means when these move closer, the perpendicular distance decreases. It means the tension also decreases. So here the answer is going to be decreases, because we are seeing tension is now less than 45 newtons. So the tension decreases. The stress in the wire is 5.3 times 10 to the power of 7 pascals. The wire is now replaced by a second wire that has a radius which is 3 times greater than that of the original wire. The tension in the wire is unchanged, so the force tension is remaining the same. Capture the stress in the wire. Okay, so we know that stress is equal to force over area. So this is going to be force. Since they gave us radius, so I'll say force over pi r squared. That's the cross-sectional area. So for the first wire, I'll say stress is going to be F over pi r squared. For the second wire, I'll say stress, I'll quote sigma 2 is going to be force is the same over pi, but the radius is 3 times, so it is 3r, but this is raised to power 2. So this is going to be F over 9 pi r squared, so which is going to be 1 over 9 into F over pi r squared. So it's like it is 1 over 9 times the first stress. Remember, this was 5.3 times 10 to the power of 7. So times 5.3 times 10 to the power of 7. So I'll just say 5.3 exponent 7, and I divide this by 9. So this is 5.89 or 5.9 times 10 to the power of 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 5.9 times 10 to the power of 6 pascals. A horizontal spring is fixed at one end. A block is pushed against the other end of the spring so that the spring is compressed as shown. The block is released and accelerates along a horizontal frictionless surface as the spring returns to its original length. The block leaves the end of the spring with a speed of 2.3 meters per second as shown in the figure 4.2. The block has a mass of 250 grams. I think 250 grams should be 250 divided by 1000, which is 0.25 kilograms. And the spring constant K is 420 newtons per meter. Assume that the spring always obeys Hooke's law and that all the elastic potential energy becomes or is transformed into kinetic energy. Capture the kinetic energy. So the elastic potential energy is given by a half k x squared, but remember this becomes the kinetic energy. So I would simply say the kinetic energy. Oh, since I have the speed, this is also going to be a half m v squared. I will first take this part here. So kinetic energy will be a half times the mass, which is 0.25, times the speed. The block leaves with a speed of 2.3. So I'll say times 2.3 squared. So 0.5 times 0.25 times 2.3 squared. So this is 0.66. Calculate the compression of the spring immediately before the block is released. So the compression of, remember the kinetic energy, all the elastic potential energy became kinetic energy. So I can simply say a half k x squared became a half m v squared. Okay, so a half cancels out. I can make x the subject, so x is going to be the square root of m v squared divided by k, since they gave us k. So I'll just substitute in this root of, the mass is 0.25, v was 2.3 squared divided by k, which is 420. So I'll say this is going to be 0.25 times 2.3 squared divided by 420. Then I find the square root of the answer. So this is 0.056. 0.056 meters. Okay. Alternatively, we would just equate this value of kinetic energy to a half kx squared and find x. After leaving the spring, the block moves along the surface until it hits a barrier at a speed of 2.3 meters per second. The block then rebounds at a speed of 1.5 meters per second. So it rebounds. So if this is positive, this should be negative because there is a rebounding, and moves back along its original path. The block is in contact with the barrier for the time of 0.086 seconds. Calculate the change in momentum. So remember, momentum is mass times velocity. So we want to find a change in momentum, which is going to be the mass times the change in velocity. The mass of the block was 0.25 kilograms. The velocity changes from 2.3 to negative 1.5 because there is a change in direction. So that becomes a plus. So I have 0.25 times 2.3 plus 1.5. So this is giving me 0.95. Then the average resultant force exerted on the, of course, the rate of change of momentum is the resultant force. So I'll say resultant force is equal to the change in momentum over time. So this is going to be 0.95. The time of contact was 0.086. So I'll just divide that by 0.086. So this is giving me 11.0. I'll just write 11 newtons. The maximum compression X of the spring is now varied in order to vary the kinetic energy, Ek. Remember, all the elastic potential energy is becoming the kinetic energy, which means the kinetic energy is going to be equal to a half k x squared. People will see this and wonder why I'm using this equation. They say the elastic potential energy, whose formula is this one here, becomes the kinetic energy. Okay, so assume that all the elastic potential energy in the spring is always transferred to the kinetic energy of the block. Sketch a graph to show the variation with x of Ek. So it means kinetic energy is going to be directly proportional to the square of the compression. So that means as the compression increases, the kinetic energy increases as the square of the compression. For example, if the compression is 0, the kinetic energy is 0. That means the graph starts from the origin. If the compression is 1, the kinetic energy is also going to be a constant times 1. Constant times 1. If the compression is 2, the kinetic energy will be equal to a constant times 4 because x should be squared. If the compression is 3, the kinetic energy is going to be a constant times 3 squared, which is going to be 9. Now when you look at the last digits here, it means Ek increases more rapidly as x increases. So that is going to be a curve of increasing gradient. It is a curve of increasing gradient starting from the origin. Okay, as simple as that. Two progressive sound waves meet to form a stationary wave. The two waves have the same amplitude, wavelength, frequency, and speed. Remember, these are progressive waves. State the other condition that must be fulfilled by the two waves in order for them to produce a stationary wave. So of course they must be moving in opposite directions because they have everything the same, but they should be moving in opposite directions. So we say they travel in opposite directions in order to create a stationary wave. A stationary wave is formed on a string that is stretched between two fixed points A and B, and the figure shows the string at time t equals to 0 when each point is at its maximum displacement. Okay, so we are having something like that. That is constructive interference. Distance AB is 0.80 meters. The period of the stationary wave is 0.016 seconds, so this is t. On the figure, sketch a solid line to show the position of the string at time t equals to 0.004 seconds. So 0.004 seconds is the same as a quarter times 0.016 seconds. That is a quarter of a period. So if we start from t equals to 0, we have this. Then it means at a quarter a period. At a quarter period, it means one wave moves to the right by a quarter of its cycle. Another one moves to the left by a quarter of its cycle. It means the path difference or the time out of step is going to be a half a period. A quarter period to the left, a quarter period to the right. That means if I consider two corresponding points on the same wave, they are a half a period out of phase, or a quarter a period out of phase. If I try to find the phase difference, this would be 2 pi into a quarter of a period a half of a period divided by t, which gives me pi. And pi is destructive interference. So this is destructive. Pi radians is destructive interference, so it is going to be a straight line, a horizontal line. So for this one, it is going to be a horizontal line. Okay, so they said label this line P. Then at time t equals to 0.02 seconds. So I have to check 0.02 seconds. What is this? So t equals 0.02 seconds. This is the same as, let me check, 0.016 divided by 0.0224. I think this is 0.024 seconds. Let me just do it. Because it is big, I will divide it the other way around. So we have 0.024 divided by 0.016. 0.024 divided by 0.016. That is 1.5. 1.5 a cycle. So I'll just consider the half cycle. So if one wave moves half a cycle to the other side and one wave moves half a cycle to the other side, so it means it is one complete cycle. Again, that would be constructive interference. But since we started with the displacement with the wave downwards, then the other one will be upwards, because we have one cycle. We have already completed one cycle. Alternatively, I could just say, okay, if this moves 0.024 to the other side and 0.024 the other side, it means if I want to find the phase difference, I would say 2 pi into, I'll multiply this by 2, 0.024 minus negative 0.024, which is going to be times 2, divided by the period, which is 0.016. And I think this gives you 0.024 times 2 divided by 0.016. So it is 3 times 2 pi. Those are 3 times 2 pi. Those are 3 cycles. So 3 times 2 pi. This is constructive interference automatically. So the other one is going to be like this. Just a mirror image of this. Okay. So then they said label this Q. So this is going to be Q. Okay, so that is Q. So the next, determine the speed of a progressive wave. So first of all, we need to find the wavelength. You notice that we have two cycles in a distance of 0.8 meters. So twice wavelength is equal to distance AB. So that means twice wavelength is equal to 0.80 meters. So the wavelength is going to be 0.8 divided by 2, which is 0.4 meters. That is the wavelength. Then using V equals lambda times F. Since we don't have F, this is going to be lambda times 1 over T, which is lambda over T. So V is going to be 0.4 divided by the period, which is 0.016. 0.4 divided by 0.016. So this gives me speed as 25 meters per second. A beam of vertically polarized light of intensity I naught is incident normal on a polarizing filter that has its transmission axis at 30 degrees to the vertical. Okay, as shown in that figure. So the transmission axis was 30 degrees to the vertical, and the intensity which went through is I1. The second polarizing, the transmitted light from the first polarizing filter has intensity I1. So it is like I1 is going to be I naught cos squared of 30. Light is then incident normal on a second polarizing filter that has its transmission axis at 90 degrees to the vertical. So it has been rotated through an angle of 90 minus 30. Because, in other words, it has been moved further through an angle of 60 degrees. It was initially 30 to the vertical, then it was moved further so that it becomes 90 to the vertical. So it has been moved further through an angle of 60 degrees to the vertical. The transmitted light from the second filter has intensity I2, calculate the ratio I1 over I naught. So I1 is equal to I naught cos squared of theta. So I1 I1 over I naught is going to be equal to cos squared of theta, which is 60, which is 30. Initially, it is 30 degrees. So we have cos of 30, but this should be squared, which is 0.75. Then I2 over I naught. So, of course, we can first find I2 in terms of I1. I2 is going to be I1 cos squared of theta, which theta is now going to be 90 minus 30, which is 60 degrees. But then I can remove I1 by substituting the previous part. So I2 is equal to I1. Remember, I1 is equal to I0 cos squared of 30. So I'm bringing this expression here. So this will be I0 cos squared of 30, then times cos squared of 60. So I have I2 over I0 equals to cos squared of 30 times cos squared of 60. So I have cos of 30 squared, that is 0. This was 0.75 times cos of 60, but this is squared, which is 0.25. So when we multiply 0.75 times 0.25, this gives me 0.1875 or 0.19. Okay, that is waves. Next is electricity. Define electric potential difference, that is V is equal to E over Q, energy per unit charge, or W over Q. So the energy transferred per unit charge from electrical to other forms, that is PD. Energy transferred per unit charge from electrical to other forms. Energy transferred per unit charge from electrical to other forms, that is PD. If it is EMF, it is from from chemical to electrical. A battery is connected to two resistors X and Y as shown. The resistance of resistor X is greater than resistance of resistor Y. So we shall say Rx is greater than Ry. State and explain which resistor dissipates more power. Remember, power dissipated is equal to I squared times R, and note that the PD, the current through them is the same. So I'll start with that statement. Current in X and Y is the same. Reason, they're in what? They're in series. So the current is the same, but we also know that power dissipated the P equals to I squared times R. And remember, R for X is greater than R for Y. The current is the same, but R for X is greater than R for Y. That means X dissipates more power. So X dissipates more power. Okay, I think that is enough. X dissipates more power. Alternatively, you can look at it in terms of PD. Because X is bigger than Y, it means V for X is also going to be greater than V for Y. Then when I use power is equal to I times V, it still means power for X is greater than power for Y. As simple as that. A battery of EMF 9 volts and internal resistance R is connected to two resistors P and Q as shown in the figure here. A total charge of 650 coulombs moves through resistor P in a time interval of 514 seconds. During this time, resistor P dissipates 4,800 joules of energy. The current in resistor Q is 4.5 amperes. Assume that the EMF of the battery remains constant. Calculate the current in resistor P. We want the current in resistor P. Okay. So let's come back here. The current here is 4.5 the current in Q is 4.5. Okay, so we know that current from charge is equal to IT, so current is going to be Q over T. They've given us the total charge through a resistor P. So charge is 650 and the time is 540. So I'll just press my calculator. 650 divided by 540. So that is 1.2. So the current here is 1.2. So if I come back here, it means the current here is 1.2. So what is the total current here? This is going to be 1.2 plus 4.5, which is 5.7 amperes. That is the current in the battery. The potential difference across resistor P. So I now know the current. I want to find the PD across resistor P. Okay. So to find the PD across resistor P, remember PD is defined as energy converted from electrical to thermal energy per unit charge. So this is energy per unit charge over Q. So the energy in resistor Q, during this time, resistor P dissipates 4,800 joules of energy. So this is going to be 4,800 divided by the charge, which is 650. Okay, so that is divided by 650. So 4,800 divided by 650, that is 7.4 volts. Alternatively, I could use a simple formula such as PD equals to power divided by current. And of course, remember, power is still equal to the work done over time taken, or energy transferred over time taken. So V will still be energy transferred over time, I times T. So that is I times T, which is still the same as 4,800. The current will go to 1.2 times the time is 540. I think it gives you 7.4 volts. So this is another alternative. I used power is equal to IV, but power is also work done or energy transferred by time. Then the internal resistance R of the battery. Internal resistance. Now I know the total current. So current I total was equal to 4.5 plus 1.2, which is equal to 5.7 amperes. And we know that EMF is the same as terminal PD, the terminal PD plus the lost volts. That is the EMF. So the EMF is 9 volts and the terminal PD. Of course, note that P and Q are in parallel. That means the terminal PD across them is the same. So this is going to be just 7.4 plus the lost volts. And remember, the lost volts is going to be current times the internal resistance. So that means I will say small r is going to be 9 minus 7.4, which is the lost volts, divided by the current, which is total current, that is 5.7. So I have 9 minus 7.4 divided by 5.7. So this is 0.28. Lastly, I think should be particle physics. Describe the structure of an atom of uranium-238. Okay, sometimes they will give this question 4 marks, so you have to describe in details. So there are 92 protons, 238 minus 92, 146 neutrons, there are 92 electrons. So I'll say 92 protons and 146 neutrons. These ones are found in the nucleus, so I'll say in the nucleus. Then I'll say 92 electrons orbiting the nucleus. Okay, since I said 92 protons and 92 electrons, I will say total charge is 0. I can also say the diameter. Of course, the diameter of an atom is approximately equal to 10 to the power of minus 10 in meters. Then I can also say that the atom is mostly empty space. Mostly empty space. So the atom is mostly empty space. So I can write everything that I know about the atom to get 2 marks or not to miss any mark. Then the decay of uranium-238 is shown by this equation. For nucleus X, calculate the ratio in coulombs per kilogram of charge over mass. So when we balance this equation, this will be 2 and this will be 4. So it means the mass or the charge is twice E and the mass is 4 times U. So the ratio is going to be twice E divided by 4U. So this is 2 times 1.6 times 10 to the power of minus 19. 4 times 1U is 1.66 times 10 to the power of minus 27. These constants are given in the list of constants. So this is going to be 2 times 1.6 exponent negative 19 divided by 4 times 1.66 exponent negative 27. So this is giving 4.82 times 10 to the power of 367. So that is 4.82 times 10 to the power of 7. Two particles P and Q consist of 3 quarks. Those are baryons. These quarks are up, down quarks. Particle P has no overall charge. Particle Q has an overall charge of positive 2e, where e is the elementary charge. State the quark composition of particle P. So particle P has up or down quarks. So particle P has a total charge of 0. So this could be up, down, down. You can check. Remember the charge of up is plus 2 over 3e. And the charge of down is minus 1 over 3e. So when you sum up, down, down, when you add 2 over 3 minus 1 over 3 minus 1 over 3, you get 0. Then particle Q has a charge of positive 2e. So positive 2e is most likely going to be up, up, and up. Because you can check, you have positive 2 over 3e 3 times. So times 3, which is positive 2e. Because there are 3 quarks. So that is up, up, up. Okay, I think that marks the end of paper 2. See you in paper 2-3. Until next time, bye bye.